Alright, so today we're going to do two things. Today I will be working on the advent of code, the day one, and we'll be doing some leak code as well, probably leak code medium. I'm thinking, what is it called? The Cocoa Bananas one. And I will be doing advent of code in Haskell, which I do not know at all. So that should be interesting. But yeah, that's pretty much it. Let us begin. I have already like this is pretty much the structure of the code. Module main where we say main IO, and then we say main is equal to, is it do? It is do, and then I think we can do that. I'm not really sure about the what's the word? Yeah, this is probably fine. I don't know if Haskell complains about white space though. But anyways, moving on. So from here, I want to read the file. Read file in Haskell. One, two. I mean, I don't get the difference. It seems about the same. Anyways, Haskell, yeah. What did I call it? No, handle. We say read file, was it? I think it was. Shift tab. Shit. Read file. And we want to read, what did I call this file? Input.txt. Okay. Input.txt. And I think they say read mode. What's the problem here? Where's the problem at? Let's open file. So we want to go back to R, change it to open file. I could have just done like a capital replace. Right. Alright, so this is not a big problem and then we get the contents using hget contents of the handle. So contents is equal to hget contents of the handle. Right. Let's just return just to get it to shut up. Hget contents handle. I wonder if there's like an issue here. I said open file. Handle, open file. Oh, I'm missing some modules. Where do these even come from? I know one of them comes from system.io. Is it? I'm pretty sure it's module system import system.io like that. System.io. It's shift tab. Okay, and that fixed all our problems. Okay. So from here. Okay, so we also have to close it. So we have to close our handle. I wonder if it's just close handle like this. No, it's H close. So we can go like this. H close. Oh. H close. Then if we do that, then I don't need to do that. So now we have, I would assume, well, actually, let's see what it is. Contents. Okay, GHC. What did I call this? Day1.haskell. And then we dot slash. Where is the dot? Dot slash day 1. Okay, so we have the raw string. So we want to split the string now at this point. So we want to say something like words. It's words. So we want to say split contents is equal to words contents, just like that. No, not good. No good. Can we say print split contents then? No, no good. Oh, yeah, it's let equals. All right. All right. So now we got just the split contents. So next, I want to. What is the length of the split contents? Two thousand. So that means half of these go into list 1 and then half of them go into list 2. I wonder if okay, I'm thinking ahead here, but I wonder if some sorting algorithms just can't be done in Haskell, because I know some of them are technically in order. Like, I don't know. We'll think about that when we get there. But for now, we print the length, and the length is 2000. So that means each of the other ones have 1,000 elements. Each list has 1,000 elements, so that means that the indexing is from 0 to 999, right? Let's see here. If I create a list comprehension to represent the indices, would that be, well, let's just try it. We let list first indices equal the list such that we start at 0, we go to 2, can I do this, and then we end at split contents, or I guess it would be the length of split contents. Let's just try this first. What? What? Whoa, what was that? LSP Haskell error? No way. I'm curious if it deletes until that. That's weird. An LSP error? I mean, seems to be working. Anyways, so all right, let's just try this. See, no, I want to get the length print the length of first indices now. Yeah. Yep. 1001, huh? Oh, okay, I get it. Okay. So, can we then say -1? I wonder if Haskell thinks of this and this as different things. Well, I guess we can try it. So this gives us 1000, which is actually what we want. Or wait, is it what we want? I think it is. Yeah, I think it is. But, let's see, if I do this. I mean, what should it give us here? Let's use... Oh, no, it changes back. It changed back to what it was before, so I guess it should give us the same thing. Yeah. Okay, so, we have the indices that we care about here. I will get one, I'll call it second indices. I'll say R1, R3. And I'll just say like this. Yeah, okay, that makes sense. Okay, and then we'll print the length of the second indices. Yup. Nice. Okay, let's print them both now. Whoops. Print first indices. I don't really like that. Print second indices. I don't like that my LSP does that. I think I can change that somehow, but I cannot really be bothered. Okay, it's a bit unclear here. Put star line. Yeah, should be good. So what is this? 0 to 1998. I've been going through something. Bam. Alright. So, yeah. Now we've got the indices that should represent the first list and the indices that should represent the second list. What do we want to do here now? I guess my plan was... I don't really have a plan past this, to be fair. I'm gonna say use elements of a list as index Haskell. Oh, I guess we could maybe do a comprehension, I think. Perhaps. Like I'm thinking, yeah, so let list 1. Also, is 1 allowed as a, it's probably okay, right? Let list 1 be the list X. No, actually. How do I get... First of all, how do I get the... Get element by index? Haskell. Haskell. Shebang. Look here. Okay. What a strange syntax. There's got to be a clean, like a better, more comprehensive way. This does not feel that that's good. Returns the index of the first element, which is equal to that. So just linear. Returning the indices of all elements in ascending order. Ascending order. Takes a predicate in a list and returns the index of the first element in the list satisfying the predicate. Damn, I guess maybe that's the easiest way. So, list, double shebang, number 1, or index, right? So in this case it would be split contents, double shebang, whoopsie daisies, double shebang, x, yeah, such that x x comes from first indices. Yeah. Oh my god! No syntax error. Oh my god, this is actually my first time writing code that does not give me a syntax error first try. And this time it'll be second indices. And so in this way, we avoid having to use iteration to get the necessary elements and store them in the list. But first of all, I think we need to get this, I think, oh, just, okay, so for this problem, I realize I'm jumping behind, like, back and forth. This is not my first time. I spent like 5 hours on this, which is why it's going so smoothly. But basically, what we're doing here is we want to relate these are two separate lists. This is list 1, this is list 2. But like for me, like the way I understand it is that this appears like this, and then it appears like this, and then it appears like this, so that it's like every second element is an element of the same list, which is why I'm doing all this, where I'm skipping, going by 2, you know what I mean? And we want to, at the end of the day, probably sort somehow so that we have the smallest to largest in this order for both of them, and then we relate the two by finding the difference and then adding those differences to get the answer that we're going to put in here, right? So that's what's going on. I guess it doesn't work yet, so like I probably shouldn't be saying all that like it's working. But let's see. GHC. Oh, I guess I didn't print it. Oh yeah, okay, I'm getting distracted here. I wanted to get to get this really. Also, I am going to reprint the split contents because I wonder if it's separated by tabs or if it's separated by something. I'm guessing tabs, right? Like it makes sense. No, I actually don't. It's not split contents. I want the actual content to be printed. So print contents. It seems to be just like spaces. That's a bit annoying, but you know, it is what it is. Yeah, probably like 4 spaces or something like that. Why does it keep opening in downloads? Day 1 ls. I'm going to test.txt probably. And vim into that. Paste. Whoops. Undo. I guess I didn't copy it. Paste it. And then I'm gonna go here and change it in. Whoops. Change in what? Change inside this. I called it test.txt, and it has been saved. I don't know why this keeps popping up. Which key? Anyways, and then I want to print both of these. I want to print both list 1 and list 2. So AGHC compile. 342133 should be list 1. 435393. Yes, sir. Oh my god, this is great. This is wonderful. Anyways, moving on. So now we have the 2 lists. Now we have to sort them, which is the actual hard part about this. I'm thinking I feel like the question said that they're almost in order, but I can't quite remember. Only off by a small amount. Wait, maybe. Maybe the lists are only off by a small amount. Pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list. Figure out how far apart the numbers are. Okay, we're gonna go in the notes real quick. And I want to go file sorting. Sorting. I mean, I guess merge sort is n log n, but it's also super difficult to write. It's got to be an easier one. I know quicksort is mostly n log n, but it's sometimes n squared, which is bruh. More like slow sort, am I right? Counting sort. Goofy algorithm. I guess it's heap sort then. Is there such thing as a heap in Java? I mean, Haskell? Java. Heap sort, heap in Haskell. I don't know why Java keeps coming to my mind. Data.heap. Yes. This is wonderful. But wait, if well, it should be okay. Is it a min heap we want or a max heap? What am I looking at here? Pair up the smallest with the smallest and the second smallest. Yeah, it's the smallest we want. It's a min heap then. Okay. Min heap Haskell. Or maybe I could use this. Maybe there's something here that I can... No. I need an example here. Oh man. Oh man, oh man. No, I don't want to implement it, bruv. Yeah. Import data.heap. I wonder if this counts as like import data.heap, is it? Is it capital H or is it just... Do I have to download this stuff first of all? I think I might. Yeah, I might have to. I've never done this before, so it should be interesting to figure that out. And then import qualified data.heap as heap. Import qualified data.heap heap as heap. Import data heap qualified as data heap. I'm actually gonna do it in this window. What's the command? What's the command? What's the command? Import external Haskell. I don't even know what it's called. Like a package? Package, I'm gonna say. Whoops. Right. So we're back. Oh, how do I import stuff? Adding an external package. Bruh. Modules. Okay, so they're called modules. The syntax for importing modules in a Haskell script. Okay, but that's... What do I do outside the script is what I'm asking about. Oh, name clashes. So this is like C++ where you use namespaces, or am I imagining things here? Okay. I'm just a tiny bit, just a tad bit confused here. What you modules. There's a module for manipulating a list, dealing with complex numbers. I'm kind of curious here. Let me say GHCI, and then I'm going to say import. What is it that I'm trying to import at this moment? Data.heap? Data.heap? Something that was interesting. Oh, whoops. Something that I thought was interesting when I was going like this said data dot. There's a bunch of stuff, but no. Like if I say bits, does that no errors? Is data.heap like deprecated or something? Data heap Haskell. I mean, it's the official Haskell language. I think. No, it's Hackage. No. Wait, that's confusing. Haskell.org? It seems like it's Haskell. Oh, oh boy. Using external modules Haskell. Not in GHCI, bruh. Oh my. Oh my. Abstract data types. Cool. Cool. Bruh. I'm not sure why I'm getting errors. Could not find. Could not find. Could not find module Haskell. Bruh. Haskell data.heap. Oh my god, that's such a pain though. I have to do this whole thing like for dependency just to solve a small little problem. There's got to be a different sorting algorithm I can use. What's the fastest? What is the fastest sorting algorithm? Quicksort? No, I don't think so. But actually, let me check. What is the condition that makes quicksort so slow? Oh, it's an in-place algorithm. This is the one I was thinking about, the in-place sorting algorithm. I feel like quicksort would be pretty hard to do in Haskell. Quick sort Haskell. From the Haskell website itself. That's wonderful! Okay, I will be using this. Even though I don't really know what it means. Order a... Like, I know what quicksort does generally, but... I mean, I guess it would be worth... It would be... No, it would... I would be a better programmer if I learned it right here. Right here. Right now. What is this chun operator in Haskell? Oh, it's the types. What is ord, though? Ord in Haskell. Totally ordered data types. What is this formatting? Doesn't matter. Okay. The ord class is used for totally ordered data types. Instances of ord can be derived for an user-defined data type whose constituent types are in ord. The declared order of the constructors in the data declaration determines the ordering in derived ord instances. The ordering data type allows a single comparison to determine the precise ordering of two objects. So, what? It's like what is it like? I feel like it's like something in Java, but I can't remember what it's called. Comparability, transitivity, reflexivity, and oh my god, bruh. What is this? X less than or equal to Y, or Y is less than or equal to X is equal true. I'm not really sure what this means, but I think it allows for comparison. So it's like what do you call it? Comparator in Java. Like when you initialize a priority queue or something like that, you have to say that you have to say what the ordering is, like whether it's less than or greater than. Maybe I'm wrong here. Maybe I'm wrong. But either way, I cannot do data.heap, so let's move on. What was the algorithm? What was the algorithm? It's not here. It's not here. It's here. So quick sort was defined. I'm gonna go up here. Quick sort was defined. Ord A. I don't know what this equal. Is a type class constraint. Means that loop. What? Loop? I thought there was no iteration in Haskell. What's going on here? Loop works with any type A that is an instance of the num and ord type classes, corresponding to numeric types. Bruh. Basically, you can think of loop as having the type on the right-hand side of loop as having the type of the right hand. Oh, wait. What? What? Hmm. So does that mean... Oh, I think I get it. So this relates to A such that A has to either be a num or an ordering, and then the rest are just parameters, I would assume. I'm not really sure what this means. So it takes in A, which is either of these things, and then it takes in a function T that returns, or am I, wait, I'm so confused. What does this mean? What's all that about? You know what, that's not my code. That's not the code I have to understand. But I think I get it here. So it's a type class constraint. We're constraining A. I'm gonna just double check to make sure. Constraint. Okay. I mean, I think that's what it is. Like, we're saying that A has to either be a number in order or an ordering. So let me actually test this theory out here. I'm guessing that if I... 1 second. Yeah, that'll do. Sell down. The type signature for loop lacks an accompanying binding. Oh, right. Like, we don't actually define it. Let's say loop is equal to... Or yeah, loop is equal to... take from 1 to... Oops. Take 10. Oh, right. We gotta return something. Or do we? I actually don't know. Do we have to return something? Maybe. Maybe no. Anyways, if we don't get another... let's see. String... No, but it has to be... It has to be some other, like... Actually, well, let's try char, let's say, for example. Yeah, okay. So we're just... Oh. Yeah, it seems like we're just... Actually, but, like, if we were doing that, why wouldn't we just go like this, you know? And then, like... I don't know. I'm not really sure. So, anyways, A can either be... Okay, whatever. This doesn't really relate to us anymore. So, change quick sort. Where were we? Quick sort takes A, and A has to be A has to follow some sort of ordering, I think. Let's double check. No information because there's an error. There's an error. Wait a minute. No, it's an error. It's full-on syntax error. Quick sort, if it's empty, should is equal to the empty string. Solid. All right, let's check it out. What are you even talking about? What is this, bro? 1 second. Okay, let's continue. Quick sort. Well, I don't know what PXS is. PXS, like that, is equal to, what is this actually all about? Anyways, is equal to quick sort lesser plus we're adding two lists together, P plus quick sort greater. Interesting. Okay. Let me say where lesser is equal to filter by less than P XS and greater I just by you know, just by using our head a little bit would be greater than or equal to P, perhaps XS. Is that allowed? I don't know. Yes, sir. Yes, sir. What mistake did we make up here? Redundant bracket. How about shut up, bruv? Alright, so let's see. We're given two numbers, I'm guessing. How do we call this thing, though, is my question. Oh, P2XS or what? So A is a list with an ordering, I'd assume. And then P, XS. I'm just a bit confused. It seems like P is maybe an element. Or actually, I don't know what P or XS is. Let's ask. The worst thing in the world. What does this mean? What is P and XS? pattern in the second case. Matching syntax splits a non-empty list into two parts. P is the head of the list, the first element, and XS is the tail of the list, the remaining elements, which is also a list. If the list is this, then P is that, and XS is that. Based. How it works, P is the pivot, XS contains all the other elements. A lesser list is formed by filtering elements in XS that are less than P and greater. Whoa, that's actually kind of cool. It's formed by filtering elements in XS that are greater than or equal to P. Poggers! Okay, the quicksort algorithm is then applied recursively to lesser and greater, and the sorted results are combined with the pivot in the middle. Yo. Wait, where does the middle step happen? Oh, that's this thing. Interesting. Whoa, that's so sick. That is very cool. Whoa, so quicksort is this and this, where lesser. Whoa, that's actually so cool. Wow, that's pretty nice. Cool. Wow, cool. Okay. So let's try and call it and see if there's a breakdown in communication. Let's sorted 1 equal quick sort list 1. Seems to be good. Whoops. And then we want to print sorted 1, sorted 2. All right, so we write. Dude, I gotta stop doing the capital letters. So we GHC. We run. Oh, that's very cool. That's actually very cool. I really like that. I want to. Oh, dude, I think I want to write more Haskell. This is pretty fun. Okay, so it worked for the smaller lists. Should we try then for let's see, 14. Yeah, 14 up, and then we say change inside that, and then we say input. I think I called it that. .txt. And we go down. We compile it. We do that. Sounds a bit harder to see, but it seems like it's sorted. No, yeah, it is. Okay, cool. And all that remains is to get the difference. I wonder if there's a simple way to just. I have the two lists. I want to subtract all the elements in the first list. Yo, I actually think there's an awesome thing I can do here. This is very fun. I really like Haskell. Debugging is kind of hard though, I feel like. Let's see. So let's say let diff list equal diff list is equal to diff list is equal to x, where such that how do I get the elements at that again? I think it's the shebang thing, right? So such that sorted, though, how do I know? I guess maybe ABS. Is there an absolute value function? Yeah. Wait a minute. How exactly should this go? Should it be that like all of these are going to be bigger than all of these? Like all of these are going to be bigger than all of these? Or it'll be just the difference. Like what should it actually be? I guess. Oh, it's just the distance, so it won't ever be a negative number. Okay. So yeah, I guess it is ABS. So we do a list comprehension such that Wait, actually, how do I do this? Hmm. Damn, I was gonna be clever here, but I really do not have time. So we want to subtract all elements in one list by all elements in another list in Haskell. Given a list of numbers, I want to subtract a constant. Nope. Nope. Yeah, this is what I want to do. What the hell is this? Why would you want to do this, though? Also, this is not Haskell, my friend. Okay, I did not word that correctly, I feel like. Whoops. Okay, I said x such that how to do this? X is I wonder technically what the time complexities of these would be. So let's say I let the indices be equal to a list that starts from 0, goes to 1, and then it goes like that up until the length of sorted 1. Honestly, it could just be list 1 minus 1. First of all, I'm gonna just print that. Print indices. Yeah. Yeah. Whoa, that's a lot of stuff. GHC. GHC. This is hard to see. I don't need these anymore. I know that they're sorted, I think. I can probably confidently say that they're sorted. Perhaps, perchance. GHC. Day 1. Yeah. Yeah, this is what I want. 0 to 999. Yep, that's good. Yeah, so we let the indices be that, and then we can say let diff list, I think is what I called it. Let diff list be a list containing the element x such that x Hmm. What did I do up here? Let's list shebang x such that x is first in this. Okay. Oh. Alright, so we're going to say sorted one double shebang y instead. Can I say such that again? Or is that no good? Such that y comes from indices okay, so like that then. Such that x is equal to okay, alright, I'm gonna stop trying to do it like this because I think it's a bit unclear what is going on. So let's see. List by list in Haskell. No, this is not it. This is not it at all, bruv. Let's see. List Haskell. Haskell. Huh? Okay, okay. This isn't really, like, I didn't really write this in the functional style, I feel like, but what can you do, genuinely? Alright. Alright. Okay, we've actually hit a bit of a block. Because I don't think I can say let def list equal to sorted 2 minus sorted 1. This kind of thing is no good. No instance arising from that. Is this something that can be solved using recursion? I'm not really sure. could be solved in recursion using like a stupid way. Like, ugh. There's got to be a cleaner way, I think. There's got to be a cleaner way. Is this lists? Okay, so this is X. So take an X from this list. So this is actually how we get about doing like quote unquote iteration or filtering, I suppose. Okay, not only can we have multiple predicates in list comprehensions, we can also draw from several lists. When drawing from several lists, comprehensions produce all combinations, then join them by the output. Here's what we do. X times Y such that... Okay, so that could be interesting. We can say ABS X minus Y. Is something like this allowed? Cool. Okay, such that oh yeah, that's it. That's the one. Such that X, I don't know what this arrow thing is. It's just not super clear to me, but you know, whatever. And it's a comma, right? So Y is equal to sorted 2. Bruh. I thought there was an ABS function. I guess it doesn't work like that. Actually, wait, no, that makes no sense. Why would it not work like that? Wait, what? Absolute. Wait a minute. Absolute value. Haskell. That's what I said. That's what I said, bruv. ABS. Is this what I need to do though? Yeah, I think so. Wait, what is this? All the possible combinations? That's not really what I want to do. I just want to subtract two lists. Okay, what was the error message we were getting when no instance for that? What if I said ABS sub X and Y? What? There's gotta be some way to do this. What? No instance for num string? What does that mean? Oh my god, is it still a string? Wait. Sorted 1. Control L should be to clear the screen, but it did not clear. Nah. Anyways, GHC. Do that. Oh, how is this being sorted then? What? That's so weird. And it actually looks like the sorting is correct for the numbers, but I guess that's to be expected, maybe. Let's see. At what point should we turn this into numbers? Probably here, right? Okay, so I'm going to change this to num list 1, num list 2, and then I'm going to say let num list 1 be equal to list of strings to list of integers. Haskell. Oh, just read. To num takes string. Wait, string. I have not been using that class. Is it int capital? I guess it is. It actually works too. And then to num is equal to, is it map? Map read or something like that. Bruh. Anyways. What are you talking about? What was that? Error condition? Oh, yeah, it's down here. Yeah. Num list is equal to num. And we pass in, oh, I see. String list. Okay. We pass in list 1. Replace with 2. Oops, and nope. Oops, whoops, whoops, whoops. What is even going on? Replace with 2, bro. Replace with 2. There we go. There we go. Very nice. So now we have it in numbers. I wonder if this is now gonna work. I mean, it looks promising. Whoops. Okay, it compiles. Let's print the diff list. I mean, is it even worth printing? You know what, though? Let's go 16 down. Change inside this. Change this to test.txt. Right. Bro. Right. Jesus Christ. Christ. We compile. We run. Okay. And then we want to print the diff list. Print the diff list. GHC. Run it. No, this is not what I want. Why is this longer than this, bro? This can't be. How do I do this? Why does actually... So it's all the differences. Why does it do that, I wonder? I think this is a question for AI, because for some reason this is not a common issue. If I have 2 integer lists and I wish to subtract all the elements in one list by subtract index, index by index, how would I do this in Haskell? So zip with minus list1, list2. And why does that work, I wonder? Zip with minus Cool. Now we want to get the absolute value of this, because look, it's minus 2, I should say. Oh, it does look like all of one list are bigger than all of the other list. So if I go sorted 2 and then sorted 1, then I get all positive values. I wonder if that's the case if I go here, 16 down, change inside this, Then I say test, yeah, input.txt. I guess it doesn't matter if it's, yeah. Yeah, no, that's not gonna work. So, I guess I do. I guess it does matter. Test.txt. Let's see. Can I modify the code, bruh, so that the result of the subtraction is the absolute value of the subtraction. That last is just bruh. What is this backslash? Zip with X, Y, ABS, X minus Y. View pattern expression context. What does that mean? Oh, is it because of this backslash thing? I don't even know why. Okay, let's try it. Bruh. Okay, there we go. GHC. Okay, I guess it worked. Let's go up to the line 18. Up. And then we go to change inside that. And then we want to replace with, what it is, was it called? Input.txt, I believe. Okay, very nice. Now we just want to sum everything. Whoops, I meant to go like that. Alright, so now what do we want to do? Sum all. Wait a minute, I think I can figure this out by myself. No, I can't. Elements in list Haskell. Why? Why all this yap just to do this? Oh, that's pretty gangster, I'm not gonna lie. Yeah, we're doing that. We're doing that. Because I really like this whole... So sum list... the types. It takes a list of strings, I believe. No, it takes a list of numbers. Integers, really. And then it returns an integer itself. Is this valid? Chat, is this valid? So what's the difference between an integer and an int? D until that. And then here we want to D until the end. Anyways, sum list base case is when sum list is given this, it should return that. No, it should return 0. I'm trolling. And then sum list is equal to how do we get the head of this thing again? I can't remember. Okay, so I'm actually a bit confused at like why we keep doing this like xs thing, and then we say it's equal to, you know, x plus sum list of the rest, so xs plus. I don't get it. What did I do wrong? What did I do? What did I do? X to xs is equal to x plus sum list xs. Use folder found. Why not? What are you on about, dog? It's just an information thing. I don't even know. I think we could even use guards for this kind of thing. Maybe. Perhaps. But I have no idea. I'm not a Haskell pro. What am I looking at? Sum list is equal to 0. Is there supposed to be something in between these, or like what's going on here? I don't know. I don't even know. Ban for ban, I copied you. You betrayed me. You betrayed me. How dare you? Do we have a... Yeah, this is a guard, no? Oh, is that it? No, it's not it. I mean, let's see if it works. Where do we want to call sum list? Sum the list, diff list, and then print it. Is this the answer? What? A part 2? No way! No. No way. There's actually no way. Your analysis, oh my god, there's no way. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. How often each number appears in the right list? Calculate a total similarity score. There's no way, bro. There's actually no way. I can't believe this. I can't believe this thing. I just got debated so hard. I just got debated so hard. There's no way. Oh my god. Okay. Let me see. Can I do something like this? No, no good. No good. Okay, then I'll just put stir len. The sum of the differences is, yeah, that'll do. That'll do. That'll do. I'm not sure what this use folder found. Why not sum list access folder? I don't even know what the hell they're yapping about. I'm just gonna ignore that. That's whatever. Okay. So this time we'll need to figure out exactly how often each number from the left list appears in the right list. How often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. What? Okay, I'm taking a break, bro.